Okay, so for this one, we are getting into finding the area of an ellipse. And we don't have a whole lot happening here on our graph paper. It might be good to refresh yourself on what an ellipse looks like. And just so you know, in the assignment, there is a link to the geometric shapes and area presentation. So you are welcome to reference this at any point as you work through the assignment. Especially now once we're getting into ellipses and then later getting into the polygons. So that will come into play here in a little bit. But for right now, we're just looking at an ellipse. And we were given for the question, it says an ellipse has an area of 4.71 inches squared. So we have an area is equal to 4.71 inches squared. Okay, so that was given to us. And a minor axis that is 2 inches long. So this minor axis is 2 inches long. Solve for the major axis, which is going to be this horizontal one. So we can take a look at this. We have our minor axis going from top to bottom. Major axis is the longest one. So if this was rotated 90 degrees, the major axis would still be the longer axis. It's not dependent upon where it's located on the circle, but rather how long the axis is. So if I rotated this 90 degrees, the major axis would still be the longest axis. So just so you know, whenever we look at other ellipses, so you don't get the confusion between what is major and what is minor. The major axis is the major axis, the longest line, whereas the minor axis is going to be the shorter line through the center of the ellipse. Okay, so we were given the minor, which in this case is 2 inches, and we are solving for the major axis. So we're solving for this axis right here, solving for this. And then we need to sketch in the ellipse using that found dimension, but we don't know what it is yet. We've got to find it. Show only those dimensions needed for the area calculation. Note each grid unit is 0.25 inches. Well, that makes sense on here because 1, 2, 3, 4, that's 1 inch. 1, 2, 3, 4, that is 2 inches. So each grid unit is 1/4 of an inch, and that tracks based off of the information that has been given to us on this graph paper. Okay? So the formula that we're going to use is area is equal to pi times A times B. So we know what the minor axis is. It was 2, but we need half of that for B. So only half of 2 is going to be plugged in for B. So coming back over here, my minor axis, while it is 2 inches long, I only need half of that. So half of 2 would be 1. So luckily the math for that isn't all that difficult. So we know what our B is going to be. So the formula for finding the area of an ellipse is area is equal to pi times A times B. Where we have B, we need to find A. All right. And we also have area as well. So I'm going to plug in what I know. So 4.71 inches squared is the area, is equal to pi times A, which we still don't know, and then B, which is going to be 1. Okay. Well, now we need to do our order of operations, but in reverse so that we can get A all by itself. Now, pi times 1 is just pi, so I'm going to negate that 1. And now we need to get pi. It's being multiplied by A, but to do the opposite of multiplication would be division. So I'm going to divide by pi, 4.71. So we need to check that out. 4.71 divided by pi is equal to 1.5. It's very clean. So A for our major axis is 1.5. Now remember, that's just for half of it. So 1, 2, 3, 4, that's 1 inch, plus 2 more, 1.5. 1, 2, 3, 4, that's 1 inch, plus 2 more, 1.5. So now we have our total major axis drawn in there. So A is equal to 1.5 inches, which means our major has to be 3 inches total, which that works out nicely. That is 3 inches. Okay. And then the next step was sketching in the rest of my ellipse, which this is a solid C- effort right here, but hopefully you understand where I'm going with this. Okay, so that's how you solve for the ellipse.